All right, let's do a word problem. Now that we know a little bit about vectors, let's start using them. So we have a case where you have two football players sandwich a runner, and they that each have 5 newtons of force, and they each come at an angle of 30 degrees from the center line of the runner's velocity. If the runner stopped just before impact, what is the resultant force? Okay, so there's a lot to unpack here. And the key with word problems is going to be trying to break this down completely. So we have this idea that the football players sandwich the runner. So, I mean, to sandwich them, they're going to come from opposite ends. Now they have 5 newtons of force apiece. Now, if you're not familiar with physics and newtons, it's not a big deal. It's just it's a very standard unit of force. So just for practical purposes, just use it as a black box. And they each come at an angle 30 degrees from the center line of the runner's velocity. So that means if the runner is running down, in some direction, doesn't really matter what, because we're going down his center line of velocity, the other players are coming and hitting him here to kind of sandwich him. And we know that, again, they're 30 degrees, but they're sandwiched. So one's 30 degrees this way, one's 30 degrees that way. So if the runner stops short of impact, so he doesn't actually contribute to this force, what is the resultant force that happens upon him? So you have to think through these word problems. You have to think through exactly what's going on. You have to kind of it helps to construct a diagram. You could do this without constructing a diagram. More power to you. I can't. So let's describe the runner here. Not a very attractive runner. He's just a black box. And if this is the velocity line, if he's running downwards here, then we could think of the players coming in at 30 degrees off center. They're each coming at 30 degrees off center. They're coming up. So the reason this is convenient for us is we can think of their force being in sort of almost like a positive direction. Kind of makes our lives a little simpler. And each of them has 5 newtons of force. So we know the magnitude of each of these vectors. Now, the direction's a little bit different because if it's 30 degrees off center line, then the actual angle of this vector, is going to be 60 degrees because it's that the 30, 60, 90 triangle. And the angle of this vector, if that's 60 degrees, this is actually 120 degrees, right? You have to think about each of these vectors as kind of having its origin point here. So if I have a little coordinate system and a little coordinate system, that's a 60 degree vector, and that's a 120 degree vector. So if I call this vector player 1 and I call this vector player 2, so the forces that are coming from them as P1 and P2 respectively, then we can find the resultant force by constructing a vector for P1, constructing a vector for P2, and summing them up. So if we say P1 is its magnitude cosine, and we're going to call this theta 1 because that's the angle for player 1, I plus magnitude for P1 sine theta 1j. All right, we're going to say that. Now, we know that the magnitude for both players is 5 newtons. And we know that theta 1 is 60 degrees, and we know that theta 2 is 120 degrees. So that tells me that P1 is 5. I'm going to leave off the newtons for now, but we can think about it later. So 5 cosine 60 degrees I plus 5 sine 60 degrees J. So remember, cosine of 60 degrees is 1/2. So that gets me 5/2 I plus 5 square root of 3 over 2 J. So that's player 1. So player 2 is his magnitude cosine theta 2 I plus his magnitude sine theta 2j. So again, that's 5 cosine. Now in this case, it's 120 degrees I. And in this case, it's 5 sine 120 degrees j. And, you know, it's always helpful to remember your unit circle. If you don't, that's going to be, if you think about it, these look almost the same. So the positive I, this is going to be positive, and that's going to go in the negative x direction. So that's negative 1/2 I. But these both go in this direction. So 5 square root 3 over 2 j. So negative 5/2 I plus 5 square root of 3 over 2 j. So that's player 1 and player 2 respectively. Now we need to put this together. We need to add these two vectors together. Player 1 plus player 2. So a lot of times it's easier to stack add them. I like that personally, so I would say 5/2 I plus 5 square root of 3 over 2 j, negative 5/2 I plus 5 square root of 3 over 2 j. So the i's actually cancel, and you only have a j vector. So notice this is 5/2, so that's just 5. So it's 5 square root of 3 j newtons. So this is another example why you want to use component vectors, because when I look at this, I can automatically know that that force is only in the j direction. Now let's use our intuition here and see if that makes any amount of sense for what actually happened in this situation. So we've got a runner, and he's running, and two guys hit him. Well, if they hit him at exactly the same angle, the forces that come this way are going to cancel each other, because he's going to get knocked this way by one player and this way by another player. So he's going to be shaking, but he's stood straight up. But then their forces coming in here is going to kick him back. So if he's coming in this negative direction, they should be pushing him in the positive direction. So it should hit him and do this. Now, if you study physics, you're going to know there's a lot more going on here. You're going to have forces. You're going to have energy loss to deformation. There's going to be some elastic force in addition to the inelastic force. But that's not what we're dealing with here. We're dealing simply with the vectors and a purely, let's see, is that inelastic or elastic? It's been a long time. But I believe that's a purely elastic collision that we're dealing with here. But anyway, so the idea here is we have this vector, and that is our answer.